The end user, a major appliance manufacturer. The application, a machine-bending steel tubing, specifically the tubing on the bottom of a refrigerator. The controls challenge, reduce wiring, cabinet space, and the 90-minute changeover time. The machine builder, specialty tooling, Evansville, Indiana.
When I'm laying out a control enclosure, the things going through my mind, the thought process that I go through is, where is it going to be the easiest for me to bring my I/O cabling in from the machine? What kind of components do I have? Am I going to have 480 volts, 3-phase in this application? Am I going to have 24 volts DC only? What kind of supply power? What kind of drives, control? What kind of communication cables am I going to have? And obviously you have to think about this stuff. How do you isolate the high voltage stuff and the low voltage stuff to keep noise out of the equation? If you've got some communication going on that is sensitive to noise, how do you isolate that? So the thought process to lay out a control cabinet is very important. You have to make sure that everything is placed correctly and isolated well.
The choice was Bosch Rexroth's MLD-M control architecture.
This is a 4-axis application. I wanted to be able to reduce my panel size. That allows me to do that by the master axis containing the PLC or motion controller capabilities. That reduces the need for an external PLC that's going to take up more panel space. Another reason for that is the capabilities of the drives, the way they wire together. I'm using the Servo 3 interface, which is a single wire connected daisy chain from drive to drive, and then it daisy chains out to my Servo 3 I/O blocks, which again, another space-saving technique was using those I/O blocks. They give me one single point to terminate my sensors. They allow for up to a 3-wire sensor termination and reduces the amount of wiring and time needed to put the panel together.
Why not use a traditional PLC?
In a traditional architecture system, I would have had an external PLC or / motion controller that would have had I/O cards built into it. I would have then had to wire the I/O points from the I/O cards to terminal blocks that were located in a separate portion of the panel for ease of wiring access for the end user. In this situation, by using the S3 Servo I/O blocks and the MLD-M architecture, all that's reduced, and I saved approximately 25% on the size of my panel needed.
The Bosch Rexroth solution also saved 35% on wiring costs and results in a much cleaner panel, and improved productivity by 15%.
We've got a scenario where the operator needs to enter into the work cell to load a part, and then when the cycle is complete, be able to get back in the work cell to unload the part. And this presented a unique challenge, because typically when you have an operator going into a work cell, while they're in there, the drives would have to have the 480 drop to them in order to meet the OSHA specifications. With the MLD Safety on Board technology, we were able to put the drives into a safe stop condition where the operator can go in there and come out of there and be completely safe and not have to worry about dropping 480 and then having to recover and re-enable drives and all the different things that go along with that.
A one-vendor solution.
One reason I like to use the Bosch Rexroth control products is there is a single software package called the EnderWorks Engineering, and it allows me to build a project. I can have motion controllers or the MLD PLC control and motion control built right into a single drive for smaller applications. I can integrate my drives with all the parameters, all of my PLC and motion programming, and my HMIs and motion, or the programming with the HMIs, and also the I/O is all comprehensive inside that software package, so you can drag and drop to build the entire project and then have one piece of software you're working with them to program and integrate and execute the entire project.